Alright, we're going to get started here today. So, before I talk about any of this stuff, we're going to talk about firewalling today. But before I do any of that, I did grade lab 7, I think it was. That was the WordPress load balancing one. You should see your grades on D2L. Also posted 2 new labs about the content we talked about last week. So we talked about disk partitioning in the video from Monday, and then we talked about what did we talk about on Wednesday? Forget. Oh my goodness. Backups. We talked about backups on Wednesday and Friday. And there's 2 labs that are relating to those topics on D2L. So any questions about the grading or about any of the labs, things that you want me to talk about related to the class? All right. Okay, so firewalling. So I hope most of you are a little bit familiar with the basics of doing firewalling and stuff. We're going to talk about how to do firewalling in the Linux environment, and there's a number of different ways we could go about doing it. And the first way that we're going to try and look at it is the traditional iptables route. And iptables has kind of been how people have been doing firewalling in a Linux environment for a while now. But there's a lot of new, there's a new kind of core way that's coming out, net filter and things along that path that we could talk about. And then there's UFW down at the very bottom, uncomplicated firewall, which is probably the way that you'll end up doing things. But iptables is applicable to a bunch of different environments, and I think it's definitely worth knowing how to use it. The reason why people might use UFW or some other type of firewalling solution over iptables, though, is iptables does have quite complicated syntax, and it has a lot of different things that can go right and I guess go wrong with it. And it's a bit challenging to know, but there's just a kind of a core functionality which I'd say is important that we're going to cover. Basically, we're going to look at mainly TCP, UDP type things. A couple other things you might need to do is some ICMP stuff, various other protocols that you might work with on your device. But you can kind of go into the manual pages as needed and look at these different things. So oh my goodness, so sick. So in our Linux environment, we have this iptables command, and that's how we interact with iptables. That's how we establish firewall, add rules, list rules, things like that. So if I say iptables-l, that will list all of the rules that I currently have available. And then there's 3 chains by default on a Linux system. There's input, forward, and output. So input is traffic coming to your device. Forward is traffic kind of going through your device. If you have forwarding set up, we're not really going to look at that today. It's kind of for a later date. And then output is traffic originating from your device going somewhere else. So interesting things to look at here are policy accept. So that means that by default, our default action on this chain will be to accept traffic. Other policies that we could have would be, what do we have here? We have reject, drop, and log, and we're going to talk about what the differences between those are. And those are, at least reject and drop, are definitively negative conditions, whereas log is actually logging the traffic so you can come back and see it later. So if we wanted to change the default action for, if we want to change the default action for one of our chains, we would say -p, what our chain is. So we'll say, let's just say output, and then we'd say j, this -j, and then we'd specify what we want the default to be. I could change it to drop, I could change it to reject. Let's say if by default it was accept, or let's say by default it was a drop or something, I could just say accept. Like that, and it would change the default policy for that chain. And we're going to come back to that. If I was to change my output policy to drop right now, my SSH session would terminate, and it would just be not fun. But we'll come back and we'll show specifically how we would allow SSH. in a little bit here. But that's how you change the default policy. So for actually working with rules, we have two different ways that we can do things. We have append and we have insert. So rules are processed from top to bottom. So if we have a rule that comes before that says accept, and then we have a rule later on saying reject or deny, that accept rule will be processed, but the deny rules won't be. So if we need a rule to take place before another rule, we need to use insert. So we could say where we want the rule to go, where we want the rule to be, and then the actual rule itself. And we'll go through all that and look at it a little bit more later. But those are the core things that we can really do with the iptables commands. And then the next section we have here is the actual rules themselves that we're going to work with. So just as an example here, I'm on SSH right now. So let's go ahead and specifically allow SSH, and then I'll kind of explain what we're doing and what's happening here. So let's append to input. So we want to allow traffic coming in. We're going to say PTCP, so we specify the protocol, and then we specify TCP. And then if we specify the protocol as TCP or UDP, we can specify a destination port. So we say dport 22. And then we would jump to accept. If I go iptables L, it will show us that we have added this accept rule for TCP destination port SSH. Now if I was to change our policy on input to drop, well, let's do this demo first. So I'll just netcat LP8888. So I'm going to listen on that port. If I was to go just open a netcat session, I guess, to that port, you can see we can exchange information and it'll pass freely. And that applies to any other port on our box right now, since our default policy is accept. So again, to change that, what we do is iptables. What do we got here? Default action -p. This is just, again, this is why people might want to use UFW instead, because this stuff is a little bit hard to remember sometimes. But I would say input. That's our chain that we want to target, and then we want to, let's just say, drop. If I do iptables L now, that will say our policy is drop. If I was to try our little example from before, netcat there, I try and connect, and we wouldn't get anything on this side. So I suppose this is a good time to kind of look at the differences between drop and reject. We'll look at kind of what it means, or what it would look like first, drop versus reject, and then kind of think about what it would actually do. So I'm going to change the default policy on input to reject. Did I spell that wrong? Bad policy. Maybe I'm not allowed. I might not be allowed to do reject there. I might only be able to put reject in my actual jump in my rule. I might not be able to do it that way. So what I'll do is I'm just going to show reject by actually writing a rule specifically for that port. So I'll say iptables, or we're going to append input PTCP dport 8888. Then we're going to J to reject. Alright. Now, when I am trying to connect here, it actually will stop right away. So the difference between dropping and rejecting is dropping, if we see traffic that applies to our rules, we're just going to completely ignore it. There's going to be no TCP information sent back. Normally, when we're closing a connection, we'd kind of do like a fin and then a reset. But with drop, we just don't even acknowledge that there's anything listening. We just immediately discard that information. Now with a reject, I believe what's going to happen is we're actually going to send a reset packet back to whoever was connecting. So that was why there was the difference of behavior here. When I was connecting this first time and typing this information, it wasn't coming through. My client on this side had no idea that the actual server was just ignoring all of that information. And Netcat in the background was still trying to connect. It was still trying to establish a TCP session, and that's why I was just able to type information here. But when I was doing it this time, Netcat immediately saw that reset packet and just gave up and didn't try anymore. If I was to connect to a different port that didn't have that specific reject rule on it, you can see Netcat's still trying. If we were looking at this in Wireshark, you could probably see it's trying a bunch of times to actually connect, and then eventually it does actually time out. But it doesn't time out nearly as fast as when we connect to a port that's immediately rejecting it. And that's just kind of interesting, and that's a common practice when you're doing firewalling stuff. So one of the reasons we probably couldn't use, now that I'm thinking about it, that we couldn't use reject on our default policy is we can probably only use redirect when it's coming to TCP. So if we specified P TCP and we say reject, that's probably why we can only do that. But then again, there is responses in UDP and ICMP and a lot of other protocols that actually specify rejecting stuff, but that's neither here nor there. So we talked about D port. If I wanted to also do S port, that's something I could do too. So I'd say S port more relates to kind of input traffic. So if you want to prevent somebody from connecting to a specific service, you could say S port on input. Or you probably want to say D port on output. I haven't really used S port very much. You probably just want to use D port, and so on and so forth. So I mean, let's do this example too. Let's say UDP really quick here. I guess we can, yeah. It actually, we can reject in UDP too, so I don't really know what's going on there. But we can see we used UDP just the same. So really the things that you want to remember are this P. So you specify the protocol, you say what the protocol is, you say D port, the destination port, and you say J to where you want it, whatever your target is, and that's pretty much the core of what you need to know. We're going to come back and talk about logging in a second here. I actually have a logging rule in effect already, and we're going to come back and look at that in a second. But this is also the other important rule that we have, and this is one that I kind of just have sort of memorized. This is working with the states on the actual packets. So this is on output actually. So we could just block traffic on input, and right now only traffic. Let me try something here quick. So yeah, okay, that would actually be on input and on output actually, and we can do it on. I'll come back to it. So right now we're blocking all traffic on input except for traffic that was meant for SSH. And then we have a couple other rules there too. One more thing that I want to do before we move on is look at flushing iptables. So that's one of the other things we can do is clear all of the rules. So I'd say iptables F and then a chain that we'd say we want to clear out. If I want to clear all of our rules from everything, I would just say -F without any arguments. But one of the other things to be aware with when you're doing an iptables F is you definitely want to be looking at what the default policies are. If I was to flush out my IP tables right now, and my policy was default drop on input, my SSH session would be terminated because it would then be blocked. So if you're flushing things remotely, you definitely want to make sure that your policies are probably all accept. So I'm just going to go and reset my policy on input to accept again. And then I'll run iptables out. Recall the iptables output from above, and then we'll compare them. So now we're back to the factory defaults of absolutely nothing, and we're all accept. Okay. Now we're going to come back to what we were looking at before. So I'm going to just change add my SSH rule back there, and we're going to say drop is our default rule on input. Look at that really quick again. But the one thing to note about that is, okay, we're only again allowing SSH traffic in. If I was to try and like ping Google or ASDF or whatever, or connect anywhere, or apt update or anything, you can see that's just hanging there right now. That rule also blocks all outbound traffic. So we need a rule that would allow essentially new traffic outbound. So we are allowing traffic outbound, but the traffic coming back in is not being allowed. So that's what this rule does right here, is it allows related and established TCP sessions to come back in. The responses from our things. So if I was to just going to copy that. Syntax is a little bit messed up there. And now I was to apt update. We can see that the TCP is working now. And I think ping would also work. Yeah, we can see ping is also working. So right now we're at a state where the system's pretty good and it works pretty well. The other thing that you might want to do is block outbound traffic too. If you're running some sort of secure host where you might have users that are trying to be malicious and things like that, preventing them from actually sending traffic, you would go into output and add output rules to where they can actually connect to. One of the typical things that you might see is you allow output traffic specifically to, let's say, the update servers, to your local network, to a load balancer or something like that, but nothing else. But I don't think I'll get into output very much right now. If we wanted to lock things down, I guess we could just remove this rule, and that would prevent us from connecting anywhere. But the interesting thing about that is it wouldn't prevent data exfiltration, let's say, because if you were using UDP, you could send stateless information out of the network, and it would never actually get hit by that input rule if it was never requesting anything in response. So in that case, we want an output rule to prevent people from doing anything. If I wanted to, let's do this. If I wanted to only allow SSH, and I wanted to do that to prevent that kind of data exfiltration stuff, what I could do is change this to output, from a UDP context at least. Change that quick. Change this to output, and this would allow, again, those related established TCP sessions from SSH from above, and I could say iptables p output drop. Now if I was to and try and ping something, it wouldn't allow it anymore. But the other interesting thing to note is it would say ping unknown host asdf.com. So one of the things that we've happened to have done here is killed DNS. So DNS is the other service that you kind of need to be careful about allowing. So inside of our output chain, we would need to allow DNS basically, I think. And we might be a little bit broken with this related establish. I'm not exactly sure how it's tracking that. But what we'll try and do here is add 53 DNS as something that we're allowing on output. So output PUDP dport 53 J accept. Ping's still broken, that's fine. But at least see we have ASDF actually being resolved now. So it's resolved, it's just not being allowed to actually ping it because it did not match that output rule and it fell through to the default policy of drop. And unfortunately, I don't remember my ICMP rules offhand. You might be able to. Let's just try and do this. Enables. Let's just say we want to allow ICMP specific. Let's try it specifically to ASDF.com. So yeah, I don't think I actually talked about this specifically, but we have this -S and -D, which are applicable to all protocols, I think, at least from IPv4 standpoint. The source IP address and the destination IP address. So if I wanted to allow ICMP traffic specifically there to ASDF.com, what I think I could do would be append to output, and then I could do PICMP. Hopefully I can do that. And then I would do a lowercase d for the destination IP address, and then J accept. Alright, spelled iptables wrong. Tables L, we can see we have our new rule right here. And then if I was to ping ASDF.com, you can see we actually did get that ICMP going through like that. However, if I was to curl ASDF.com, we wouldn't actually get anything in response because we're not allowed to send TCP traffic out to that host. If for some reason we wanted to just allow all traffic to a host, it would be pretty easy. We could just do iptables, A output, D, J drop, or accept. And that would allow all traffic to it without specifying any protocols. So if I added that and then curled, then we'd get data in response. So that would work. So final thing I want to talk about with iptables is logging. So before I do any of that, I just want to clear my output rules. I kind of got a little bit messed up there. So again, we do iptables L. We would see our policies drop. Probably want to reset that. And then we could do iptables F output. And we can see we cleared all that out, so that's straightforward now. So let's talk about logging then. So we can actually log traffic that's coming into our host if we wanted to, and we have this log target that allows us to do that. So the thing to note about the log target is it has to happen before the reject or the drop one. The reject or the drop one, I believe, will be processed immediately and won't work. And log will also have no effect on, or log will be basically a pass-through rule which will be processed, so it won't actually do anything with the traffic itself. So if I wanted to log a specific occurrence of somebody trying to connect on a specific port, but still deny them access to doing so, I'd need to have two different iptables lines. I'd have a log line, and I'd have a drop reject line. But for right now, we'll use the default policy of drop to handle the drop condition, and we'll just use log otherwise to look at that. So let's say we want to log all occurrences of somebody trying to connect on port 80. What we can do is iptables, let's just append to input ptcp dport 80, and then we'll j to log. All right, so if I was to go over here and let's curl my host here, and then look at the syslog. So logging was something we haven't really talked about very much so far in this class. Something we definitely need to spend more time on. And it's something I kind of wanted to just get a bunch of services up and running, WordPress, Apache, Nginx, so that we could actually have a lot of data kind of being generated for us to look at logging more in depth. That's kind of why I've been holding off on talking about it. But anyway, we're going to look at the syslog here. So that's in var log syslog. So syslog is information that's generated by the kernel, and in certain cases, other system processes, services. We can see we have a bunch of cron things up there. We have probably DHCP too, and things like that that are always running. But we can see here we have a bunch of lines that are saying that we had denied a TCP connection. So there's lots of interesting information here. We can see we have an interface, we have MAC addresses, source and destination MAC addresses, IP addresses associated with all of that stuff, but we don't have any data actually. And if we were trying to save all of the data of all of the TCP connections, that would probably not really be feasible. But certain organizations might choose to do that, and there's certain support for doing it. So pretty straightforward. If you wanted to log something, you would just do the log target. The one thing you might want to do is use a log prefix. So you can see when we were looking here, it just says Ubuntu kernel, and then it just prints this information. And you could kind of figure out, programmatically looking at it as a human, that that's what the information you want is. But if I was trying to just find all of the iptables log entries from this entire file, it would be kind of challenging. And then what we probably want to do again is add this prefix. And what that would do is just add something at the very beginning that would specify what the actual line means. And we'll come back to that in a second. So in order to do that, we need to add this directive, this log prefix, and then say what prefix we want. But before we do anything else, we should probably delete the old one that we had, and that's something we haven't really talked about yet. Deleting iptables rules. Clear. iptables L. So it's not something I think I'd had up here. So we can actually have this command to say line numbers. So this is helpful when we're doing the -I and when we're doing this other one, -D. So if I wanted to delete a specific rule, I could say D and then our chain name. So I'd say input, and this log one that we had, I could say input 3, and that would delete the third rule on our iptables. So that's how we would figure. If we had a bunch of rules, we wouldn't want to like count down one by one. We could say -- line numbers when we're saying -L to actually say what the numbers of each rule is or are, and then we can specifically target it. So let's go back to log really quick here, and we'll say log prefix, and I'll just say TCP firewall. And this might actually be something that's not supported by Ubuntu. Okay, I just put it at the wrong position. I had to put it after log because we didn't recognize log directives until after we had said we were going to try and use log. So let me try and connect one more time, and then look at our system log. And now we can see we have this prefix right here, this TCP firewall. And what I could do is use grep to actually look through our system log and only pull out lines that have that particular pattern. So if you remember using grep, we'd say TCP firewall, or whatever our prefix was, and then var log syslog. And we can see we matched only those lines in the log which had that prefix. And that's something that's definitely worth doing if you were trying to pull out all of this information. And we'll probably spend a little bit more time going back and looking at this when we get into logging. So that's our prefixes. Final thing we should do really quick is look at inserting again. So what this rule number means. So if we looked at all of, when we're saying line numbers here, I don't know if it inserts at that number or if it inserts after that number. Let's just test it out really quick and find out. So let's add another log directive for port 443, another common one that we might want to log connections to. But this time, instead of saying append to our chain, we're going to say insert, and we're going to try and insert it before number 3. So let's just try and insert it at 2 and see if it replaces 2 and pushes 2 down, or inserts it after number 2, which is kind of a good thing to know. So we say chain and then our rule number. And let's say iptables L line numbers. And we can see it actually bumped this number 3 back down 1 and inserted it at position 2. So if I needed to have one particular rule before another rule, I'd specify the number of that rule, and then it would just bump that existing rule that it was in position 2 down to position 3. So that's how we do that. Again, if we wanted to delete it, we just say iptables D input, and then we wanted to delete, so we'd say number 2, iptables L, and we can see that that particular rule is now gone. So, final thing that I want to do is talk about iptables and their persistence. So by default, iptables aren't persistent in a Linux environment. If I was to reboot my box, all these iptables would be cleared. They wouldn't actually, again, persist throughout all my sessions across reboots. And we have a couple utilities that we can use to prevent that from happening. And I actually have them installed already. Let me just remove them quick. So we have this netfilter persistent package, and we have this iptables persistent package. So in order to keep our firewall rules across reboots, we need to install this iptables persistent package. So we'd say apt install iptables persistent. And it's worth noting that iptables persistent is part of this netfilter persistent package. And netfilter persistent is actually the service that's running, and iptables persistent is just a plugin to that service. And it's a little bit complex, but I think it works. So we'd say systemctl status netfilter persistent. Can see it's active. So when we installed it, it was enabled by default. Again, if it wasn't enabled for some reason on different distributions and things like that, we could say systemctl enable netfilter persistent. And then what we would do is, after we've added iptables rules and everything, we would say netfilter persistent save. And for all of the plugins to netfilter persistent, it would run through and run these different commands. And in this case, it's running IP4 tables save, IP6 tables save. We haven't really talked about IPv6 stuff, so we're just going to rely on this. And what that actually does is it creates files in this etc iptables directory, and it has rules.v4 and rules.v6. If I was to look at rules.v4, it wouldn't actually hasn't actually updated correctly for some reason. This is from my example that I did earlier. I think what might be happening is this might be going somewhere different. I'm going to see if I can open this up and actually see what's going on. Filter. Oh, it's interesting that it didn't work. I'll try and run it again, see what happens. Oh yeah. Oh, what? That's weird. That it must have restored. I think what happened was it restored my old rules when I was installing the package because I had files left over from before. Probably ran restore on completion. So I'll just flush this really quick. Add 22 again. Policy input drop, and then we'll run it again. So iptables or netfilter persistent save. Now if I look at my rules v4, now we can see that there's this kind of pseudo iptables syntax that we've seen from the command line, but this is just a file description of what would happen. So it's saying input drop, and then it's saying input except for TCP22. And what's happening behind the scenes is it's actually using these iptables save command, which generates these files that kind of describe iptables in a way that can be processed in a batch, I guess. And then the iptables restore command, which takes a file from standard input to actually restore, and it goes through line by line and does these different things to restore our iptables rules. But you install netfilter persistent, you say netfilter persistent save, and you're pretty much good to go. Yep. Okay. So we're running out of time here, and I don't think I'll have enough time to talk about UFW. So I think we'll just leave that off until Wednesday. It should be very brief. UFW syntax is much easier to understand, I guess. But as soon as you turn on UFW, iptables kind of becomes challenging to work with. So UFW actually just uses iptables in the background to do everything. But when we enable UFW, it really, like, our iptables L there's just a million different little things that it's trying to do in the background. But once you enable it, it's probably something you can just enable and use. But for instance, the syntax is much simpler, like UFW, instead of, we had dport 22 accept and all of that. Relatively verbose. If I was just to say UFW allow SSH, much more simple. And the other thing to note about UFW is a lot of the packages that we install actually come with built-in UFW support. So when we install a web server, when we install some other sort of service, it will automatically configure UFW to actually allow that traffic. So we're going to get into that more later, but I think we'll just call it good for today. So if you have any questions about any of this stuff or any other stuff, as usual, feel free to stick around. All right.